right, and our next speaker is online, but we're gonna use a video due to connectivity concerns. I'm gonna take a stab at the name, but please do correct me. Is it Thabo? Okay, pretty close at least. All right, so we'll get this switched over here in just a moment.
Hello everyone, my name is Thabo Hlatshwayo, a PhD candidate at the University of KwaZulu-Natal in South Africa. I will be presenting to you my work on mitigating the roadkill of raptors along a section of the N3 highway through the use of raptor patches, a project that is currently undergoing in South Africa. Providing the background of my study, well, as we may all know, raptors are apex predators and scavengers that play an important role in maintaining ecosystem balance through controlling prey populations and cleaning up carrion. However, it is also important to note that their tendency to scavenge roadkill or hunt near open roads often make them vulnerable to vehicle strikes, which can lead to fatalities that could disrupt their critical ecological role. The study area for the current project is the N3 National Highway, which is one of the busiest road networks in South Africa. It connects Johannesburg and Durban, which are South Africa's largest and third largest cities. You can just imagine the traffic volume. The landscapes that the highway intersects are dominated by agricultural activities such as plantation, natural patches of forest, and grassland ecosystems, as well as several river and wetlands. All these provide suitable habitat for raptors. As such, high raptor density coupled with heavy traffic volume results to increased rates of roadkill, causing a serious biodiversity concern. It is worth noting that some of the landscape that this highway cuts across are suitable habitat for the African grass owl, which is listed vulnerable in the IUCN Red List. This emphasizes the need for studies of this nature along this highway. The research questions that motivated our study are two. Firstly, we questioned if there is evidence that raptor patches have reduced raptor roadkill in their vicinity. Secondly, if raptor patches appear to be effective in reducing raptor roadkill, where further raptor patch installation should be prioritized along the highway. As part of our method for understanding raptor roadkill along the N3 highway, an analysis of raptor roadkill data dating back from January 2012 and June 2022 was conducted. This has allowed us to identify sections of the highway that are associated with high raptor roadkill. Site visits were conducted to assess the characteristics of the vegetation stratification along the identified hotspots. Guided by the results of the site assessment, the installation of 4 raptor patches was recommended as a trial mitigation. After installing the 4 raptor patches, they were monitored using camera traps for a period of 2 years. Therefore, in 2025, a GIS predictive model was conducted to assess the effectiveness of the 4 raptor patches using geospatial data and algorithms. Our methods for building the predictive model relied on 3 input data, and these included the over 10 years georeference and dated roadkill data, the georeference and dated raptor patch use data, as well as the African grass owl distribution model. To respond to the first question, if there's evidence that the Raptor patches have reduced Raptor roadkill within their vicinity, we have collated, cleaned, and filtered the existing roadkill data. Then for each patch, we have demarcated areas along the road, starting with a 500-meter radius, followed by a 1-kilometer radius, and then 2-kilometer radius in both directions, and tabulated the number of roadkill incidents prior to the patch erection and post-erection. For controls, we have randomly selected 4 points along the N3 highway and paired them with a patch point and conducted the same analysis of tabulating the number of roadkill within demarcated distances. To identify areas that need to be prioritized for future Raptor patch installation, we have used the optimized hotspot analysis. This has allowed us to use incident points to create a map of statistically significant hot and cold spots. Moreover, kernel density hotspot analysis was used to identify and visualize areas with high concentrations of events known as hotspots across the landscape or along the highway. Then finally, as an additional consideration, we have plotted the distribution of the African grass owl in relation to the study site. This allowed us to use verified occurrence records of the species, relevant climatic and environmental variables to create a species distribution model for the African grass owl. When comparing the Raptor roadkill mortality data with the Raptor patch use data along the N3 highway, we can see that a total of 580 roadkill incidents that involve 14 known species were recorded along the N3 highway between January 2012 and June 2022, with majority of these incidents being for spotted eagle owl and barn owl. Then when we check the trends for the Raptor patch use data, we can see that a total of 25,827 Raptor visits were recorded within the 4 Raptor patches, with majority of these visits coming from the black winged kite, the barn owl, and spotted eagle owl. It is also important to note that a total of 11 known species have visited the Raptor patches, with African grass owl also having some visits, as we see 25 of those, as well as the red-footed falcon, which has a near-threatened status on the IUCN red list. It also had a considerable number of visits. Interestingly, when we check the performance of each patch, it is evident that at some point the patches were successful at reducing Raptor roadkill within their vicinity. For instance, when we check patch number 1, pre-installation 0 roadkill and post-erection no roadkill observed, and this is within a 500-meter radius. Then when we check, we push further for a 1-kilometer radius. Pre-installation, we have 1 roadkill reported, and post-installation, we have 0 roadkill reported. Then we push further again to 2-kilometer radius. Pre-installation, we have 4 roadkills reported. Then post-erection, we have 0 roadkill reported. Again, let's go to the control side for page number 1. Pre-installation 1 roadkill, then post we have 2 roadkill. We do have roadkills where we don't have the patches. Then we push a kilometer further. Then we see we have another roadkill, 1 roadkill. Then post we have 4 roadkill, Then we push for further 2 kilometers from the Perches. We have 2 roadkill. Then post, we have 6 roadkill. Then let's check the performance of patch number 2. Within a 500-meter radius, pre-installation, we have recorded 5 roadkill, and post is 0 roadkill. Then you check within a 1 kilometer radius, we have recorded 9 roadkills. Then post erection is 0, 9 roadkill. Then we push a little further to 2 kilometer radius. Pre-installation, we have 20 roadkills reported. Post is the installation of the patch, none, 0 roadkill. And if we could check, the pattern is just like that throughout. Even for patch number 3, we pushed for a 1 kilometer radius. Here we have 5 roadkill reported pre the installation, but then post the installation we have 0 roadkill. Then we push for 2 kilometers. We have a total number of 15 roadkills that were reported pre the installation, but post the installation of the patch, 0 roadkill reported. So from this result, we can draw recommendations that Raptor patch could potentially reduce the roadkill of raptors if they are positioned strategically, although robust monitoring is still needed to make sound conclusions. When we look at the map, the spatial analysis, as indicated by the optimized hotspot analysis, has indicated that the locations of the 4 installed Raptor patches were well suited and within roadkill hotspot for raptors. And this indicates the sections. When you check at the far north there, the rectangular polygon, which is more like red or orange like, so that's where the current 4 patches are installed. And if you check, we go further down, we have another polygon which is predicted there when you check just south of the highway, just before Sidara. And I think that's where the model like recommend that further patch can be explored along this region. And I think this could give us a nice opportunity to compare the patterns as to say, are we gonna observe the reduction that we see in the Hitlerberg site there. Furthermore, statistically significant hotspots where patches could be installed and prioritized are also indicated, as shown by the polygon, the rectangular polygon at the north, at the south there, just before Sidara. When we check what the kernel density hotspot analysis tells us, we can see that it has indicated the location along the highway that have high concentrations and densities for raptor roadkill. As you can see at the site where there are orange to red colors there, those are the sections that have high density values. And if you check at the north, just up there, the highway, that's where the current 4 patches are located. And as you go down, you see the density kind of like varies. But then if you go further down north, that's where high density values are also appearing to be being indicated. And again, these are the sections that needs to be prioritized as far as Raptor patch installation is concerned, or prioritization of the patch is concerned. So this also shows we have proven that the patches are working, and now the models assisting us to model where areas needs to be prioritized as far as the patch is concerned. When we look the results of the distribution model of the vulnerable African grass owl, we can see that suitable habitats for the species were identified by the model. Furthermore, several habitats have coincided with verified sightings of these species recorded on the Bird Laser app. Some of these habitat patches, we can see that they are bisected by the highway, which put the species into greater threats. We can separate from the confirmed presence, habitat with confirmed presence of the species, as well as the habitats that have potential presence. And some of these patches, they are intersected by the road. You can tell here, which also indicate areas where patches could be made to accommodate these species as well. As I conclude, it is important to note that although our data was sparse, our results have showed clear apparent reasons to believe that the installation of raptor patches 300 meters away from the road has indeed reduced the incidence of raptor roadkill in our study area. As shown in our analysis, indeed within 2 kilometers radius, either side of the patch, no roadkill incidents were recorded post the installation. Conversely, the randomized control points continued to show roadkill incidents during relevant time periods. As such, we recommend that more robust monitoring of the patches be conducted in order to make sound conclusions regarding their effectiveness in reducing raptor roadkill. Thank you for listening. I am happy to take any question that you may have.
Do we have any questions from the audience? Go ahead, Fraser. I'll try to repeat it for.
I was wondering if you could speculate, what do you think the mechanism is that would reduce roadkill around a perch? Like, just because it's a perch, why would that reduce roadkill for that animal?
Yeah, so the question, if you can hear us, is what do you think the mechanism is that reduces the roadkill near the perch?
Thanks for the question, and I think it's a relevant one. So before we started with the project, we realized that there was a section along the highway which emerged as a hotspot for raptor roadkill. So what we did, we undertook a survey with a team that I work with to gather this data or to collect this data. So the survey was that they need to, if they see a raptor species along the road, they must take a photograph of that individual and send in our group. And from that survey, what we discovered is that a lot of owls were using road signages and other objects that were closer to the highway for perching or for even feeding. So the idea that make us to think that maybe the perches could make a contribution to reduce these incidents was that when we checked, the landscape was mainly open grasses with no tree, with limited objects for perching. So the idea was that if we put safe perches for these raptors, it will kind of like attract them away from the road because they will have the tallest structure within the vicinity where they can perch safely, feed and hunt. So that's the idea that we had. And we just said, okay, let's just give it a trial and test if it's gonna work. And from the preliminary result, we can see that at some point, it has reduced the incidence of roadkill in the sections where they were located. So that's the plan that we have. Thank you.
We have another question from the online system here, and it's wondering if you had any feedback or ideas for how we might reduce raptor roadkill in areas that have more trees, so perhaps natural perches.
Another interesting question. So for now, because from the analysis that we've done, we discovered that roadkill were killed in landscapes that were open, that have no trees. So our focus has been to install these structures in areas that are open, that have limited perching sites. We've never explored along sections that have trees or that have or like alternative perching objects for these birds. So that's an interesting question, but I may not have like an answer for it. Thank you.
A few more in the audience, so go ahead. So I don't know who raised their hand first. Let's go here, and I'll repeat it.
The heights of the perches, how does that compare to the power line corridor we see in some pictures?
Yeah, so the question was what are the height of the perches, and how does that compare to the power line corridors that may be present in some of the areas?
Pardon, come again?
The question was, what's the height of the perches, and how does that compare to the power lines that are present in some of the photos?
Oh, thanks for the question. So normally we recommend that the structure becomes the tallest object within the vicinity. So the ones that we have, they are approximately 6 meter high. But again, we avoid to put them closer to power lines because we are trying to reduce the risk of electrocution. So we make sure that the area where we place them, it's kind of like some distances away from where we've got electric wires and other things that could put the species into danger. But we recommend that the structure become the tallest within the vicinity so that it could be the one that attracts more birds for perching. Thank you.
Take one more from the audience. So the question is, what was the distance that the perches were from the edge of the pavement? How far were they from the road?
So from the road, we recommend a distance of about 300 meters away from the road. We don't want them to be far apart from the road because now they won't serve any use for the roads, because if they are far, the birds can use them, but they can still visit the roads. But if they are at a reasonable distance away from the road, them attracting more birds away from the road, like the risk, the chances are high, as opposed to when they are far away from the road, or when they are too close again, they pose a risk because they will also increase bird activity along the road. So we recommend a 300 meters away from the road.
Can you repeat the distance? What was the number?
300 meters. 300 meters.
300 meters.
Yes.
Thank you. All right, I think we'll transition to our next speaker, but thank you. Let's give Thabo a big round of applause.
Thank you so much.